Hi, I'm Maddy from Reclaim Protocol. I was told to not keep this talk like super technical, so I'm going to try to share some experiences that we've had in deploying ZK in the Web 2 world predominantly, and some of the things that I learned kind of the hard way. And I'll probably try to share some of those with you today. Yeah, the first thing that came to me is, we've always been thinking of Web3 as the thing that we are building, which almost implies that it is something that comes after Web 2, right? So everything from Web 1 migrated to Web 2, from a blog-like internet structure to like social media-based internet, and now somehow it's going to go into another form of the internet. Though I think I came with this baggage that this is actually going to be true, but when we've been selling to enterprises, this is glaringly not true. Like nobody really thinks of this blockchain ecosystem to be the successor to the social media kind of an internet that we've been having. Not to say that what we are building is not useful or not important, but it's that it's not being viewed as the next iteration of the internet. However, what is being seen as the next iteration of the internet is, of course, AI. Like if you go ask anybody on the streets and ask them, hey, what do you think the internet is going to look like in a few years? What is going to be the major trend that it's all going to follow? It's definitely going to be AI. And from that perspective, I feel categorizing web or the crypto ecosystem, the blockchain ecosystem as Web3 is a misnomer, and I personally carried a lot of baggage just because of that definition. I'll talk to you about what those definitions were, which got challenged as I've been selling to enterprises. And I think what I want to appeal to over here with this talk is I think we need to start building more of this export mentality from Web3. That is, we've been building all of this great technology, ZK, MPC, and a bunch of other amazing technology. But I think we need to meet the world where it is at today. And I think that is the way to take this technology out and actually get adoption and make the world a better place. Right? So these are like the two key, very high-level concepts that I'm going to be talking about. And before I get into how I arrived at these kind of learnings, I want to talk to you about what Reclaim Protocol itself is for a few minutes, and then give you like specific examples of where my mental models got challenged as we were selling this product. Okay, I'll quickly give you a recap. So for those of you who don't know what Reclaim Protocol is, here's how it basically works. So now let's say you go onto something like Spotify, and over there you're asked to prove that you're a student in order to be able to get a student discount. Now, how do you prove that you are a student at, let's say, Stanford? Right? So that's kind of the problem statement that we work with, not just proving that you're a student at Stanford, but like trying to prove any credential about yourself. But for this example, let's just stick with proving that you are a student at Stanford. Right? So now how can you prove to Spotify that you're a student at Stanford? Let's look at a few solutions. The first one is Spotify just goes and partners with all of these universities and says, hey, Stanford, expose me an API, and I can verify the details that people are putting in on my website against your API. That way I can be sure that this person is actually a student at your university. Then you do that with Harvard, MIT, IIT, whatever. Just do it university after university. The problem is the industry leader in this kind of an approach is this company called SheerID, and they've been doing this for 12 years now, and they have only 5,000 universities that they've covered, which is just 20% of the 25,000 universities that exist in the world. And as you might guess, it just gets harder and harder as you go towards the longer tail of universities that are there on the planet. The second very simple solution is, hey, why don't you just prove that you have a @stanford.edu email address, right? So I could send you an OTP. You can verify that, okay, this is an email that I sent to xyz@stanford.edu. You can verify that. The problem with that is it doesn't really tell you much, because it does not tell you whether you're a student right now, are you an alumni, are you a professor there, are you a janitor there? Nobody knows. It does not give you that fine-grained information. And more importantly, a lot of universities allow people to continue to use their @stanford.edu email address for far longer than they are a student, right? And if you also extend this further, you also do not know information like, hey, is this a BTech student? Is this a PhD student? Is this a computer science student or a humanities students? You don't know all of those fine-grained information, which you could potentially get. Sorry. And there's a third method, which I didn't even care to put a slide up for, is you could ask the user to take a photograph of their student ID, upload it, and use some AI model to figure out whether the ID is actually true or not. But all of us over here would know that it's super, super easy to morph all of this data, and it's just like very, very inaccurate. So yeah, I want to quickly summarize the problem. I don't want to spend too much time on Reclaim protocol. I want to move on to the more interesting stuff. The problem that we are trying to deal with over here is we first of all want to verify some information about the user, right? So that's the first thing, obviously. Like, okay, is this person a student? Is this person a BTech student in computer science? Whatever. Like, we want to verify something about the user, right? The second thing is we don't want to go and make partnerships with these thousands of institutions all around the world to have them attest as to what these credentials are for the user. Just that it's like operationally too heavy. We don't want to go down that route at all. And lastly, we want the information to be reliable. Like if somebody is saying, hey, this person is indeed a student at Stanford, you want to have like some guarantees that, yes, this person is actually a student at Stanford. Right, so these are like very, very simple. Like I think this is super intuitive. This is probably the kind of guarantees that you would want from a system like this. And the key insight that we had at Reclaim Protocol is, hey, all of this information about the student is probably already present on a website, on a web portal. That is their student web portal, right? This information is already present. Stanford is already displaying all of this information to the user once they log in. Can we use that information to convert it into a credential that can then be shared with Spotify's of the world? Right? And there's a dumb way to do it. The dumb way to do it is, hey, you're claiming that you're a student at Stanford. Why don't you give me your username password for your Stanford student profile? I'll log in on your behalf and check what information is being displayed on that website after I log in. And again, for this audience, it might be super trivial to see that this is a huge security concern. Now, once you have stored the username password in the plane on your database, you become the target for all these hackers to come and try to breach this data, which happens over and over and over again. Right, so what we essentially do is we use zero-knowledge proofs to prove that this is indeed the information that came from stanford.edu using the SSL certificates of stanford.edu itself. So with that, you have like a high degree of guarantee that this is information that actually came from stanford.edu, which is good enough to say that this is the information that came from Stanford. Right, so there are a bunch of great podcasts on ZK Podcast, actually. You should definitely go check it out. I have one over there, but there are a bunch of other people who have also talked about these similar, or at least peripheral kind of topics around what we do as well. So definitely go check it out. I think that's a better place for you to go and understand the technology if you're interested. But I'm not going to spend a lot of time on the technology itself over here. But if you want to talk, I'm going to be around. You can come and grab me. So the following few slides I'm going to talk about, we need to meet the world where it is, and I have like a few very, very specific learnings that we've had in selling to enterprises that I want to share with this audience, especially to those who are building businesses around ZK and related technologies. This is, of course, needless to say that there is a case to be made in which whatever I'm going to be talking about does not make sense if you're not selling to enterprises. It definitely makes sense to just push the frontiers on research or on new technologies by and large. So take it with a pinch of salt. Okay, so this is largely going to be learnings from the Web 2 world. The first one, which is super obvious, is a lot of these enterprises care about ZK in the context of privacy. However, what I learned is the definition of privacy is very, very different from the kind of definition that I had in mind while I was approaching this. The first one that definitely came up again and again is privacy from the perspective of GDPR. Right? So all of these large enterprises care a lot about compliance. Now, the one thing that ZK does really well that works in our favor is this particular clause in GDPR called it basically leads to, hey, you're allowed to collect only that information about the user that is strictly required for this business use case. Not even a single byte of data other than what is required for this business use case should be collected. That's essentially what GDPR, whatever, Article 5.1c says. And using zero-knowledge proofs, you can say that, yes, this is exactly the amount of information that was shared with the enterprise. For example, if all that you want to know is this student a student of computer science, you don't want to know stuff like, hey, this person is a computer science student from, I don't know, 2005 to 2009. You don't want to know all of that information. All that you want to know is one Boolean, yes or no, is the student a computer science student? Even one bit of information beyond this is considered a violation of GDPR. So people care about this a lot. So when we are talking about privacy, I'm also talking about it from this very specific lens of compliance, that is, how can we make sure that people or the enterprises are getting the information that they need from the user, and there is a guarantee that they're getting nothing more than what is strictly required for their use case. So that is like one form of privacy that ZK is able to provide, which is super, super useful when we are selling to enterprises. And the second thing people care about is, we discussed this example of, you can just store the username password of these users, and that is a huge security threat. A lot of people care about not having access to PII from an InfoSec and DevOps perspective. That is, if you're able to walk into this room and say, hey, you don't need to spend these millions of dollars on building the security team that is going to keep all of this data secure and stuff like that, given that you don't even have the data that you need to keep secure in the first place. So like the budgets of DevOps and InfoSec oftentimes becomes our opportunity. That is the kind of budgets that we are eating into and saying, hey, that is the money that we want to kind of capture in this business transaction. But from the company side, they are like delighted that they do not have to invest time and money on InfoSec and DevOps. So these are like two things that are very, very important for these enterprises. But the vocabulary that they tend to use is not privacy, but compliance. That is, hey, ZK is so this is something that has come up again and again amongst the leadership of these enterprise teams is, hey, this is a great technology for our compliance. What they are inherently meaning is, hey, it's great for privacy from the different angles that we just looked at, but the vocabulary that they tend to use again and again is that, hey, this is great for our compliance. So I think that is an opportunity that exists in the Web 2 world that we are oftentimes not looking at as much as we should be. That's the first learning that I wanted to share. The second that I wanted to share, very interestingly, is ZK is obviously very good at integrity. That is, you can prove that this is the kind of computation that happened on certain data, and that way you can be sure that a particular business logic was executed. So you have integrity guarantees that, yes, this is indeed the kind of computation that was performed on the input data. However, the kind of integrity that we talk about in Web 2 versus Web 3 is extremely, extremely different. And here's how. In the Web 2 world, like Christy was talking about, like if you're going to be doing payments and all of these DeFi applications on chain, you need like very, very high guarantees, because once something is on the blockchain, it's irreversible. Right? So for that particular reason, you need everything to be extremely high integrity. However, in the Web 2 world, that is not extremely true. In fact, if you look at the error rates for products like Yoti is or Persona, which does your face scan to predict your age, that has 99% accuracy, does not have 100% accuracy. Now, if you're using Persona for KYC, it has 95% accuracy. In fact, the TSA at the airports in the United States have only 85% accuracy. That is 15% of the times they're stopping people who should not be stopped, or they should be stopped, but they're being let go at the TSA. So the integrity guarantees that are demanded by the Web 2 enterprises is very, very different. You do not need 100% integrity, which is kind of the goal that we were chasing, especially given that we were carrying this Web 3 baggage. Because in the Web 3 world, you need 100% guarantees because everything is irreversible on the blockchain. So this is the other learning. I think I learned this the hard way. And also to just put this into perspective, there are three things that all of these customers, whether Web 2 or Web 3, care about. That is UX, privacy, and integrity. And different enterprises have different requirements. But broadly speaking, in the Web 3 world, this is what it looks like. You need extremely high privacy. You need extremely high integrity. But you can do away with slightly worse UX. Right? On Bitcoin, if you are waiting for something to finalize, like you're waiting 10 minutes. And in the Web 2 world, that is not normal. Like, is there any product that you wait 10 minutes for? Probably not. So there is some leeway that we get in the Web 3 world that we can compromise a little bit on UX, but we need to give high privacy, high integrity. But what it looks like in the Web 2 world is, you need extremely high UX. Like even 1 or 2 seconds in latency is considered extremely bad. It might result in drop off and stuff like that. You continue to need to have extremely high privacy. I left out a little bit because just to be fair, I think the privacy guarantees that are required on the Web 3 world are more important because once it's on the blockchain, it's permanent. Except for that, the privacy requirements are also extremely high. But the place that you get to play around with is the integrity. Now, you don't need to have 100% integrity in the Web 2 space. So this is what the chart looks like. And just to put things in perspective, Web 2 demands much higher UX, and Web 3 demands much higher integrity. Privacy pretty much is important in both cases. So this is, I think this is the TLDR of my talk. I don't think I have another slide. OK, fine. I do have one more slide in which so far we have been chasing the idea that we need extremely high integrity. We need to be 100% secure from the integrity standpoint. But given these new learnings, especially for our Web 2 enterprises, we are having this new design space that has opened up because we can make certain trade-offs in integrity and still try to push the boundaries on UX and just solve the problems better for our Web 2 customers. So yeah, we are working on a new architecture that uses these learnings. We're in very, very early stages, so if you want to help contribute or just discuss in general, yeah, definitely find me, and I would love to talk about it. Cool, thanks. I hope this was useful, but yeah, thanks.